So I know for some of us, Friday's lesson and then the practice on theoretical and experimental probability was a little bit challenging. So I wanted to kind of talk you through an example. Basically, I kind of did the problem for myself. I changed how many times I was going to conduct the experiment and collected my data, and I just want to walk you through how I would think through this, because a lot of us are having trouble balancing the idea of theoretical probability versus experimental probability. So I'm going to talk you through how I would do this one, and then you can go back and either correct yours if it needs some work on it, or you can go back and finish this one up if you haven't made it to it from Friday. But this is one where on the Google side you can actually do your work right there on the page. So on the front side it said you're going to flip a coin. On yours it said it was going to do 50 times. Just to change it up, I'm going to do 40 times. So I filled into the table how many times I got heads and how many times I got tails when I flipped my coin 40 times. When the problem asks for experimental probability, you're going to use the data in your table. Okay? So it said, what's the experimental probability of flipping heads? Meaning, how often did I get heads when I flipped my coin? Well, I got 18 heads out of 40 possibilities. So experimental probability is using the actual data you collected, or that maybe you're given in the problem. And then of course you simplify. 18 40ths can simplify to be 9 20ths. And you can type right into the boxes there. And I know we're all kind of getting used to this, so don't stress if you weren't sure what those boxes are for, or how to use the Google form. We're all learning on this one, okay? Then it said, what's the experimental probability of flipping tails? Again, experimental means go to your data. In this case, I flipped tails 22 times out of 40 total tosses. 22 40ths, which is 11 20ths, because I always want to simplify my probabilities, my fractions. And then it said, what would you get when you add the experimental probability of heads with tails? So if I were to add 18 40ths and 22 40ths, I would get 40 40ths, which is 100%, which makes sense. There's really only two different possibilities in there, either a heads or a tails, so they should probably add up to be 100%, because they are all of the different possibilities you could have. Now, here's where we got tripped up. Theoretical probability. Theoretical probability doesn't care anything about the data you did, doesn't care anything about how many times you ran it. They just care that you're flipping a coin. So theoretical probability is our simple events. Remember our very first lesson. What's the probability of getting what I want? Well, if I'm flipping a coin and I want to get heads, how many ways are there to flip heads on a coin? One. How many different things could I flip on a coin? Well, I can really just get heads or tails, so that's 2. My theoretical probability is 1/2, meaning I'm expecting half of the time to get heads and half of the time to get tails. That's how a coin works. Experimental is, all right, I went and actually did the problem. What did I actually get for my probability? Because while I expect to get it half the time, we all know it doesn't come up to be exactly halfway. I don't flip 1 heads and then 1 tails and 1 heads and 1 tails. It doesn't work like that in real life. But if I were to do 1,000 or 10,000 flips of a coin, I'd get pretty close to 50-50 by the time I was done. All right, so let's look at another one here. So I did the same thing with rolling a die, but this time I did mine 50 times. Just so I was doing something a little different from yours, so that you could still go back and try your own. So it said, what's the experimental probability of rolling a 3? Well, experimental means look at your data. I rolled a 3 8 times out of a total of 50 rolls. So 8 out of the 50 times I got a 3. Well, 8 out of 50 simplifies to be 4 out of 25. I'm going to come down here. Experimental of an even number. Well, an even number is a 2, a 4, or a 6. So I want any roll that gave me a 2, a 4, or a 6, an even number. Well, I had 5 plus 7 plus 11. 5 and 7 is 12, plus 11 is 23. So 23 times I rolled an even number out of 50 total rolls. Well, I can't simplify 23 and 50, so that's my answer. But experimental is go to your data out of your total number of trials, however many times you happen to flip it or roll it. Then we come back to theoretical. Remember, theoretical doesn't care about your data. It doesn't care how many times you did it. It just wants to know how many times should it happen. How often should it occur? Well, I'm rolling a 6-sided cube. What's the theoretical probability of rolling a 3? So ask yourself, how many ways can I roll a 3 on a regular die? Well, there's only one 3 on there. My denominator is not 50. My denominator is how many different things could I roll? Well, it's a 6-sided die, so I could roll it 6 different ways. So I have a 1 out of 6 chance of rolling a 3. Down here, theoretical probability of an even number. Well, we said an even number was a 2, a 4, or a 6, meaning there are 3 different things I could roll that are even numbers out of 6 total possibilities on a regular die. So I have a 3 out of 6 chance of rolling an even number, which simplifies to be a 1 out of 2, or a 1/2 chance. So experimental is looking at your actual trials and the number of times you did the experiment. Theoretical doesn't care what you got there. It just cares about what would I expect to happen with this thing. If I'm rolling a die, each number is going to occur 1 out of 6 times. Hope that helps. Now go back to the activity. You can print it out and do it on paper and send it to me. You can do it right on the Google slide, whatever works better for you. But see what you can do and then send it to me when you're done.